All right, so now we're moving on to multiplying polynomials, which we've done a little bit in the like the warm-ups and stuff. So I'm going to go through these real quick just in case you're not, in class or something. So this corresponds to section 5.3 in your book. So our learning target is to be able to simplify expressions by multiplying polynomials. And the essential question is just how do you multiply polynomials? So by the time you're done with this lesson, you should be able to multiply a couple of polynomials, at most binomial, so two terms, by a trinomial, so something with two terms times something with three terms. Now, there's a bunch of different ways that people show you to do this. They're all accomplishing the same thing. They are all taking everything that's in the first set of parentheses and multiplying each thing by everything that's in the second set of parentheses. So some people really like the area model down here where you kind of take each of your pieces, you put it at the top of a column and at the front of a row, and then you kind of multiply, row by column. The distributive property and FOIL, as you may have learned it, are really the same thing. FOIL is just an acronym to help you remember to multiply all of the pieces, but using the distributive property, notice they took this first polynomial 2x plus 3 and they broke it up into 2x plus 3 and multiplied each one by 5x plus 8. That's one way to do that. FOIL, like I said, is just a shortcut, stands for first, outer, inner, last. And then some people like to line them up vertically and just multiply like you would multiply anything else. So I'm going to try to show you an example of each one, just so you kind of get an idea of what you might like and what works best for you. If you have a way that you like already, stick with it. All right, so here is this first one, and we're just simplifying this, and there's only actually one term out in front, but that one term gets multiplied by each thing inside of the parentheses. So I'm going to go ahead and write that down over here in my box. I'm going to copy it down. And I'm going to go ahead and use the distributive property to do that. I'm going to take that 6v and multiply it by 2v, and take that 6v and multiply it by 3. So 6v times 2v is 12v squared. And then 6v times 3, I'm just going to multiply the 3 and the 6, and I get 18v. So I would simplify that just by adding those two, the 12v squared and the 18v. So I get 12v squared plus 18v. And that's my answer to that one. All right, so now I'm going to look at a second example. And I think for this example, I am going to use the area model. So the area model, I'm going to draw a box. Each of my polynomials one goes on the top, one goes on the side. So I have 8p minus 2, and I have 6p. And I like to put the pluses just so I'm really just putting my binomials or my polynomials across the top or down the side. So now I'm going to draw a grid so that each term is either at the front of a row, so 6p is at the front of a row, and plus 2 is at the front of a row, and up here on the top, they're at the top of a column. So 6p or 8p is at the top of a column, negative 2 is at the top of a column. And now all I'm going to do is multiply row times column. So this first box in the upper left, 6p times 8p, 6 times 8 is 48, and then p times p is p squared. And now over here in the box next to that, I'm going to do 6p times negative 2, so that's negative 12p. And then 8p times 2 goes in the bottom left, that's 16p. And then negative 2 times positive 2 is negative 4. So I've multiplied all of my terms from the first binomial, the first polynomial, by all of the terms from the second one. This was just a way to organize that to make sure that I did it. Now we're going to combine like terms. So I have 1p squared term. So that is 48p squared. I have a negative 12p and a positive 16p. So that becomes positive 4p. And then I have one constant. So that would be minus 4. All right. So go ahead and pause for a minute and try out this card sort on your own. You're going to work out, and it'll tell you how many cards you have in the right spot. So there's 6 cards total. So you want to make sure that you have them sorted out. So these are your answers. These are your simplified. And then these ones are like your questions. These are your multiplication problems. So go ahead and take a minute and do that, and then come on back. Okay, so notice once I get these things here together, my number up there at the top is changing. I have 2 and 4 that are in the right place, and those would be your answers. Okay, so let's go on to another example. So now I have a binomial times a trinomial. So I'm going to use that vertical method this time. Like I said, I just want to make sure that you see some different examples of how to use the different methods, just so you can pick from what you like. So I'm going to take the longer polynomial and put it first. If these two things had been switched around, that would be fine. It's multiplication. It's the same. It's the same no matter which one comes first. Like 2 times 3 is the same as 3 times 2. 4x plus 2, if it goes in the front or behind the longer polynomial, you still get the same answer. Okay, so I'm going to go ahead and put 6x squared minus x plus 2. And remember that there's a invisible 1 right there. And I'm going to line this up, 4x plus 2. And I'm going to do this just like a regular division problem. The only thing is there's no regrouping. Like I'm not going to carry a 1 or whatever. So I'm going to do 2 times 2 is 4. 2 times negative 1x is negative 2x. And this was a positive 4. And then 2 times 6x squared is going to be 12x squared. Now, let me switch colors real quick so this doesn't get totally confusing. And now I'm going to take that 4x, and 4x times 2 is 8x, positive 8x. So I'm going to line that up right here underneath the other x term. And then 4x times 6x squared is going to be 24x squared, or 24x cubed. Or wait, sorry, I missed the term. I'm so sorry. 4x times negative 1. I'm like, why isn't this working out right? 4x times negative 1x is going to be negative 4x squared. So that's going to get lined up right here. And then now I can do my 4 times 6 is 24. x cubed, and that's probably not going to fit very well, so I'm going to try my best. 24x cubed. So I'll rewrite that down here. So I'm going to add those things up. 24x cubed is the only x cubed term, so that just comes straight down. 12x squared minus 4x squared is going to be positive 8x squared. Now, negative 2x plus 8x, positive 8x is positive 6x, and then that positive 4 just comes straight down. As you might have noticed, this is not my favorite method to do this. It does make sense to a lot of people. For me, it gets a little confusing, even with like nice lined paper and all of that. So I want you to know what this looks like. It was when we looked at the addition where you were adding straight down. I wanted you to know what it looks like, but this may not necessarily be your favorite way to do this either. All right, and now let's look at another example. How have we not done it? We can't really use FOIL because FOIL, first, outer, inner, last, really only works when you have 4 pieces. So I'm going to do another area model with this one. You could match up your 7K to each of these things, and then you could go ahead and match up your -3 to each one and do all that multiplication. You're going to end up with 6 different terms because you're multiplying 2 terms times 3 terms. That's fine. Just keep it organized. You can do it that way if you want. I'm going to try to keep it nice and neat in a area model. So let's see how that goes. All right. So I'm going to take my longer one and put it across the top. So k squared minus 2k plus 7. So that's going to be the top of my box. And then I have 7k and minus 3. I'm going to give myself a little bit more room to write, though. I am writing with the wrong thing, you guys. I'm writing with the wrong app. That's why it's not. Anyway, that's okay. I didn't like that much anyway. All right, so now, there we go. Let me redo that real quick. The thing I'm using to record this video also has a writing tool. And I was writing on it with that writing tool, not the Desmos writing tool. And then I couldn't control what I was doing. So I'm going to give myself a little bit more space because I ran out of space a little bit in those boxes last time. Okay. And then, so I've got -2k in the middle plus 7. All right, so 7k times k squared is going to be 7k cubed. 7k times -2k is going to be -14k squared. And then 7 times 7k is 49k. -3 times k squared is -3k squared. -2k times -3 is positive 6k. And then 7 times -3 is going to be -21. So you see how nice and neat like all my terms are? I really like this method. If you can keep your terms organized, distributing, and kind of make a list of them, then that works out pretty well too. It's all about the organization. So my first upper left square, that looks weird, but that was 7k cubed. So I'm going to bring that down. -14k squared and -3k squared gives me -17k squared. 6k plus 49k gives me, oh wait, that should hit, nope, that was positive. 6k plus 49k gives me 55k. And then my last term will be -21. All All right, so we have another card sort here. This should take a couple of minutes. Remember, the ones with the parentheses are what you're starting with. The ones without the parentheses are your answers. So go ahead and pause and try this out. And then come back and I'll show you the right answers. Okay, so these two go together. Notice I have 2 cards correct now. These two go together. So now I have 4 cards correct. And these two slide together. And that makes all 6 cards correct. Yay! All right, so I'm not going to show you how to do this one. This is your exit ticket. By the time you watch this, I will have added in the place where you're supposed to write your work. And then if you are interested in a little bit more practice, you were struggling with this a little bit, we do now have a school IXL account. And that's pretty great. IXL is terrific for like skill practice, stuff like this, calculation kind of stuff. Not so much for like word problems and application, but if you are interested in getting a little bit more practice with this, you can go and practice IXL for free, even without signing in. You just click this link right here and it'll take you to the lesson. However, if you don't sign in, you only have 10 problems that you can do a day. You might not want to do more than 10 of these problems. That's fine. But it also benefits me if you sign in, because then I get feedback on how you're doing with whatever you've practiced. So your login currently is your student ID at St. Cloud HS, ST Cloud HS. And the password, case sensitive, is capital B Bulldogs 23. With me, it prompted me to change my password at the beginning. Maybe it won't make you do that. If you have come in fairly new, these rosters were set up before Christmas break. So if you have come in new since then, you may not be in here unless you were in here for another teacher. So if that's the case, just get with me and I'll make sure that you have an account set up. I had quite a few new students come in. So that's it for this lesson. And we'll work on word problems with this next week, and then look at taking a quiz on this next Friday, the 20th. Okay, have a great day.